Self.
Hi, I'm Kevin Krewell. I'm a senior analyst with the Lindley Group. I'm also a senior editor with Microprocessor Report, a publication of the Lindley Group. It's a subscription-based newsletter. It's been published. This is going to be our 25th year. It was founded by a gentleman, Michael Slater, who's at the time was sort of the guru of the industry in terms of what technology roadmaps were going, the Intel and AMDs of the world, and the RISC versus CISC wars of the 80s and 90s. It was the main publication that people read when they wanted to know what was going on in the microprocessor business, and it still is today. We are the lead publication to go to a level of detail and technology that you wouldn't get in a more consumer-oriented publication.
So what's your take on this third generation Core processor?
Well, the third generation Core, to me, is two really key things. One, of course, is the 22 nanometer transistors. This is the bleeding edge of the process generation of microprocessors. It looks like they're ready to launch it. They've got the yields in place, and this is a really unique structure, and I believe Intel is by far ahead on process by at least a generation. The second thing is this is Intel's best graphics processor ever, by far. Sandy Bridge was a really big step forward for Intel. This doubles the performance of Sandy Bridge to Ivy Bridge, twice as many transistors. They're also now supporting DX11, which is the latest game interface or API from Microsoft. So the latest, greatest games should be able to run on this. In a low power part that will fit into a notebook without discrete graphics. Now this the biggest challenge for Intel right now is the fact that they still have to make sure that their drivers and their support for this graphics chip they've built into their Ivy Bridge is up to the same level and same quality as the actual transistors and design of the Ivy Bridge. That's still, I think, where Intel has its challenges, is making sure that they have all the driver optimizations. And it's hard for them. Intel hasn't done this for as many years as AMD and NVIDIA have, so I think they're playing a little catch up on that side. But from a pure transistor count, we're talking about nearly 500 million transistors dedicated for graphics on Ivy Bridge. Certainly what you'll see is with both AMD and NVIDIA is the lower end of their graphics business will start to dry up as this part, Ivy Bridge, has enough graphics capability to be able to do a reasonable quality game at 1080p resolutions. You may not get all the texturing, you may not get all the fine level of anti-aliasing that you can get at the leading edge of a GPU, but it'll make a very playable game. And a Skyrim or Battlefield 3 would probably do reasonably well in this part. It also supports OpenCL, which is a compute capability, which means that some of the more advanced video codecs and video processing applications may now be ported and use the GPU to do video processing. It opens up a whole new number of doors for Intel in the video and processing field as well as in the graphics field. So I think this is a very capable chip. Now, the part that they launched today is a quad-core version of Ivy Bridge. The part that's going into Ultrabooks is a dual-core version, so it is a different die. It's a separate part. I think Intel ramped the quad-core first because they can initially bring that out. It helped cruise the architecture with the bigger die. And then they bring out the smaller die version slightly later. That's pretty typical because you bring your big gun out first, and that's happened in the graphics business as well. They bring out the big gun first, and then the smaller parts come out slightly behind. Also, Ultrabooks, because they're a very thin form factor, takes more engineering work. So that means there's a longer design cycle to get those into the market, and I think that's another reason why you see the staging of it. With the traditional notebook sizes that we're dealing with on this launch, they could actually drop the Ivy Bridge into a design that originally was a Sandy Bridge design. So the time to market is much faster. But again, when you deal with an Ultrabook, you're dealing with a very custom design, and it's more engineering work you're going to be doing on it to make it very thin. So I think they're saving the Ultrabook design slightly later to get a bigger bang on it. Also, a lot of the work that's gone into Ivy Bridge will really show best when Windows 8 launches, and I think especially in the Ultrabook side, when you'll see Windows 8 being a really good fit for Intel's Ultrabook initiative. AMD's competitor to this part is called Trinity, I think Trinity's, hasn't launched yet. It's a little bit behind on Ivy Bridge launch, but maybe by only a month or two. So we should see Trinity launch relatively soon. And this is where we're going to be interesting to see the two side by side. AMD's made its reputation on better graphics performance. This is Intel's best graphics performance to date. On the CPU side, I think you still see that Intel's CPUs on Ivy Bridge are going to be better than AMD's. But when it comes to graphics and the throwdown between the two graphics parts, once they start shipping, I think AMD will still have an advantage on graphics, but the advantage will be much smaller than it has in the past. But I think we've got such capable CPUs today, and also if you look in the operating system itself, since Vista, from Vista to Windows 7 to Windows 8, you see that Microsoft has actually tried to improve the efficiency of each operating system. So we haven't had to deal with operating system bloat, which mostly affects the CPU. The CPU, the operating system is actually getting more efficient over time, which means there's less burden on the CPU. So a CPU that doesn't have to do as much work. The graphics, though, we're getting more capable displays and we're getting nicer looking interfaces, and that burden goes on the CPU. On the more advanced video processing applications, they're starting to use this OpenCL API, and that also throws more burden on the GPU as opposed to the CPU. So going forward, we see more emphasis on GPU performance for the user experience than we have in the past. And that's where you see this different balance between the two. Now, if you look at the die area, more of the die area is being dedicated to GPUs as opposed to CPUs, or relatively balanced now.
Great. Thanks, Kevin.
All right. Thank you very much.